All right, this is the calculator portion of the 1.4, 1.5 review. In my first video, I did the calculator part with my graphing calculator. So now I'm going to do it with DESMOS, since that's what we're primarily using for our AP test and school this year. All right, so let's read this problem. A ship is traveling at 20 miles per hour parallel to a straight shoreline. The ship is 5 miles from shore. It passes a lighthouse at noon. The distance between the lighthouse and the ship is modeled by, this is, I retyped this. I think it's supposed to be square root of d squared plus 25. Where d can be between 0 and 240, it's the distance between the ship and its location at noon. The distance between the ship and its position at noon can also be modeled by d of t, which is 20t. And t can be from 0 to 12. T is the time and hours elapsed since noon. Find the composition S of d of t and interpret its meaning and context. So first off, S of d of t, just like we do f of g of x, the next thing we usually do is sub in what is d of t equal to. So it's equal to 20t. And that is equal to the square root of, instead of d squared, I'm going to write 20t, the quantity squared, plus 25. And you need to include domain for that. So you have to keep the domain for the inner function, which was 0 less than or equal to t, less than or equal to 12. What is the meaning and context? So in general, you should always just say this models the y based on x. But of course, we're going to put context in there. You can't actually say y and x. So what's this one? This models the S. So what is S? S is the distance from the lighthouse to the ship. Models the distance from lighthouse to ship based on, what's the input here? T. Don't worry about 20t or any of that. Just t is the input variable. So based on time in hours since noon. So this is my model, and this is my interpretation. Find the distance between the ship and the shoreline at 3:30. So, and I guess it should be, the shoreline is the lighthouse still. I guess I probably worded that kind of poorly. But what this is asking us to find is S of D of 3.5. So all we have to do is plug 3.5 into this equation. So 20 times 3.5, that will get squared. We're going to add 25 to that. And we don't need to write the domain for this. We can just say, what is this about equal to? So you don't really have to graph this one, although for the next part, I do need the graph. So I had the wrong equation for this before. So let's try this again. Now, I don't think that you can write S of D of T like that. See how it's like giving me a weird, like, oh, you have too many things going on. And even if that error message goes away, let me type in square root, SQRT. It's 20t squared plus 25. See how the error message went away, but there is no graph showing up. If I put in 0, I should have a point at 5. So just get rid of the d of t part just so that DESMOS can find this. And then remember, we do have a 0 to 12 window here. So if we want to zoom this a bit better, we can put in 0, 12, and type in S of 0 and S of 12 and let it zoom fit to that. So, oh, that's interesting. It's kind of like an absolute value type graph. Okay, so anyway, and we are looking for S of 3.5. So it's coming out to 70. You can round this to 3 places, 70.178. Remember, we round to the nearest thousandth for the AP exam. They will tell you to do that specifically in the directions. So if you don't, you might not get credit for that solution. 70.178. And I like to label these things, so we're talking distance in miles. Find the time at which the ship is 150 miles from shore. So we are setting our S of t equation equal to 150. So putting this equation equal to 150, and this is where I would just solve by graphing with DESMOS. You could solve algebraically, but why do that when we can just say, okay, y equals 150, and I'm just looking for the intersection point. And I can't use this intersection point because that's negative. We're talking about a time between 0 and 12. So the time is 7.496. So t is about equal to 7.496. That's hours after noon. Or you could go ahead and calculate, that's about 7:50 p.m. is what we're saying, but you don't have to do that. That was it for the calculator part. The rest of this is non-calculator. Most of your quiz is non-calculator. You'll start with a problem like this, and then you'll switch to the non-calc part second.